So question 21, we get into multiplying, but this time we're multiplying a binomial times a binomial. So a binomial times a binomial is a little bit trickier than a normal math. Now, why this gets trickier is because when we start teaching multiplication, we use different strategies to do multiplication. So if I gave you 21, say, times 32, a lot of times we would write it like this. We wouldn't write it as 21 times 32. So we've kind of been taught to kind of write it like this. So notice that if we do this math, we've been taught to go start the two and go 2 times 1 is 2, 2 times 2 is 4. And remember, this really it doesn't stand for 3, it stands for 30. So there's a 0 that we tie in here because when you multiply by 10, it just means add a 0. So we've been kind of taught that when you get to this 3, we add a 0. And then we just continue with our multiplication. 3 times 1 is 3. And 3 times 2 is 6. And that holds up our place values alignment. So everything lines up nicely. We end up with 672. Now in algebra, we can also change this 21 times 32 to a binomial. We can write this as 20 plus 1 times 30 plus 2. So technically, another way to do this problem is actually make it a binomial times a binomial. Now, when you do a binomial times a binomial, we use distributive property twice. This 20 has got to multiply through the two terms on the second binomial. And then we got to turn around and multiply the 1 through both pieces of the second binomial. So there's actually 4 multiplications that we have to do. So if we do 20 times 30, that's going to be 600. Because notice how 2 times 3 is 6, and then there's 2 trailing zeros, so 600. 20 times 2 would be 40. And then 1 times 30 would be 30. And then 1 times 2 would be 2. So notice how we have 600, and notice how these two terms kind of go together. 40 and 30 would be 70 plus 2. So 670 plus 2 would be 672. So notice that we would get the same answer. So when we multiply a binomial times a binomial, the math more looks like this. A lot of times you'll hear us use the phrase FOIL. So FOIL kind of mimics the pattern of how we multiply. We multiply the first terms, and then we multiply the outer terms, then we multiply the inner terms, and then we multiply the last terms. So notice that we multiplied over here, 20 times 20. Notice how the 20 is the first term of the first binomial. The 30 was the first term of the second binomial. So first terms. Outer terms, notice that the 20 is on the outside, the 2 is on the outside. Outer terms. Inner terms, notice how the 1 and the 30 are inside. Inner terms. And then the last terms, notice how the 1 is the last term here and the 2 is the last term there. So we kind of have that association. So essentially what we're doing is to multiply a binomial times a binomial, we're going to multiply the first terms and then the outer terms. And then we're going to come back through and multiply the inner terms and then the last terms. So essentially we multiply the 3c through both terms, and then we multiply -2 through both terms. So 3c times another c would be then this 3c squared. And then the outer terms, 3c times 4 would be 12c. And then -2 times c is -2c. And then -2 times a +4 would be a -8. So I kind of line up my terms this way. You don't have to. So then I just bring everything down. So -8 would come down. 12c, lose 2 c's. I'm still up 10 c's. And then the 3c squared would come down next to it. So since it's a positive 10c, we put a plus sign there. So 3c squared plus 10c minus 8. So notice how, again, there's 3 terms here. There's 3c squared plus 10c minus 8. Notice how there's this term, there's this term, and there's this term. So there's a 3c squared, but notice how a plus 10c is the same thing as a 10c. And notice how a minus 8 is the same thing as a -8. So really, we can write this as 3c squared plus 10c plus -8. But typically, we don't write a plus to -8. We usually just write that as a -8. So we see it as terms. So that circle really helps us see those three terms. So notice how this would be a trinomial. And it's simplified because the three terms left cannot be combined together. So that is simplified. So notice how, again, we're not able to use our algorithm like we're used to or a calculator, but we can kind of treat it like this, like parentheses, and this kind of math does work, and we can use this math to work out algebraic expressions that are multiplied together. So hopefully you may find that helpful.